So good evening, afternoon or morning. Right, so in this tutorial we'll be talking about differentiation of trigonometric functions. Oops, is it registering? Right, so we'll be talking about differentiation, right, of trigonometric functions, yeah, of trigonometry functions, right, trigonometry. Or trigonometric functions, right? Metric functions, okay. All right, so yeah, differentiation of trigonometric functions. So we're very familiar with the very basic trigonometric functions, like for example the sine of x, the cosine of x, and of course the tangent of x, right? And once we find the derivative of these functions, right, so the derivative of sine x, if we were to find the derivative, we usually write the derivative as d dx. It'll just be the cosine of x, right? For the cosine of x, if we find the derivative, it would be the negative sine of x. And for tangent, if we find the derivative, which is the d dx, it is quite simply sec square x, right? And also, besides these basic three trigonometric functions, we also have the reciprocals as well. So obviously we have the cosecant of x, or cosec x, which is obviously equals to 1 over sine x, right? So it's just 1 over sine x, and the derivative of it, right? So d dx or cosec of x would be negative cosec x times cot x, cotangent of x, okay? And the cotangent of x, cot x, actually is basically 1 over tan x, and obviously a derivative of cotangent of x would be negative cosec squared x, all right? And of course the last of the reciprocals we have is sec x, which is obviously 1 over cosine of x, and if we find the derivative of it, it's quite simply sec x times tangent of x, okay? So this is basically the 6 trigonometric functions, right, where we find the derivatives. Obviously the basic 3, sine x, cosine x, and tangent x, along with the reciprocals, cosec x, cotangent x, and secant of x, right? And besides these 6, we also have the case for inverse functions, so inverse trig functions, right? So for the inverse trig functions, right, I'm gonna write this down here. So number 7 would be sine inverse. For sine inverse x, if we find the derivative of it, okay, it's a little bit different. It's not a trig function, it's just simply 1 over square root 1 minus x squared, okay? Given that x actually itself is, the modulus of x is within 1, meaning to say that as we recall, right, is just x is between negative 1 and 1, okay? And likewise for cosine of x, the inverse of cosine of x, if you find the derivative, equals negative 1 minus x squared, alright? Again with the same restrictions, okay? Modulus of x is within 1, and yeah, seemingly you don't have space actually, but I'm gonna have to write it here. The last one is tan inverse x, alright? So if we do the derivative of it, okay, we end up having 1 over 1 plus x squared. Okay, so that's for tangent itself, and there's no restriction actually, right? As long, yeah, there's no restriction actually compared for the sine inverse or cosine inverse. There's actually no restriction at all for tangent inverse, by the way, right? So yeah, so these are the differentiation of trigonometric functions that we need to know, and it's not really a must for you to memorize them. They'll normally give the formula for the derivatives, right? But if you do have to memorize them, then yeah, that's quite unfortunate. You do have to memorize them, but I don't believe you do need to for most cases, simply because they'll be given to you. You just need to know how to apply these derivatives in solving the problems, right? And without further ado, let's go and proceed to some problems. But before we jump into some problems, actually, let's talk a little bit about chain rule, right? We talked about chain rule in the last video, but actually there's a much how do I say, quicker way to do chain rule, actually, a much faster way to do chain rule, actually, right? Let's have a look. So we have this example I'm going to give here. So let's say, for example, y equals to sine, okay, x squared. Actually no, let me modify the problem a little bit. Right, let's see. So sine squared x cubed plus 2x squared. Okay, and the question asked you to find the derivative, or dy over dx. How are you going to do it? So normally what will you do is that we would obviously use the chain rule, right? Because we see that the first squared is basically here, right? Sine squared. So if we were to rewrite the function, it would be, so sine, okay, x cubed plus 2x squared to the power of 2. Okay, that's what it means. So we normally, in chain rule, we normally substitute this out with a letter itself, okay, any constant you want to put, it's a u. So in this case, it would be y equals to u squared, right? And u equals to sine x cubed plus 2x squared, right? And of course, this x cubed plus 2x squared will obviously take another substitution as well, probably put a v, right? And therefore u would be in terms of sine v, right? And then we have v, which will be x cubed plus 2x squared, right? So as we differentiate these three equations, intermediate equations, so dy over du is just 2u, and du over dv is just cosine of v, and dv over dx, okay, is just 3x squared plus 4. So once we try to find dy dx, okay, let me just, okay, so once we find dy dx, it will just be dy over du times du over dv times dv over dx, okay, and once we plug that in, that's just simply 2u times cosine of v times, well, 3x squared plus 4, okay, and of course you have to substitute it back, so it'll be 2 sine square x cubed plus 2x cosine of x cubed plus 2x multiplied with 3x squared plus 4. Okay, so yeah, that's the derivative itself, actually, using the chain rule. Now it may seem okay, but if you get very long functions, the idea of doing chain rule over and over again may seem tedious. It will seem very tiring, I'd say, right? It would seem very tiring if function is lengthy, right? If you have a lengthy function. Let's say if you have a lengthy function, it can get very tedious, right? So therefore, I would like to introduce you a slightly faster way or modified way of chain rule, okay, which will of course guarantee you the same results. So what I'm gonna do is erase all this, right? Okay. So this method is called as I'm gonna call it as in and out, okay? So just like the fast food joint, okay, so in and out, this method is basically like that, in and out method. Alright, so this is a very cool nickname anyway, but well, let's proceed. Okay, so we have this function where y equals to sine squared x cubed plus 2x squared. So what I suggest in the in and out method is to obviously prioritize on the outside function, right? So I'm going to rewrite it like this: sine x cubed plus 2x squared to the power of 2. Okay, so the in and out method, okay, well, it should be more of out and in actually, but I like in and out more because of the name. It sounds like a fast food joint. So the first thing we should do in an in and out method is to really focus on the outside, really, right? So we're gonna focus on the sine that is squared. So that's the first focus, and we're gonna differentiate it. So in this case, the power that goes outside will be obviously here, right? So we'll have 2 sine x cubed plus 2x squared, right? So that's the first thing we did. We differentiated out, but we're still not done yet, actually, right? So what's the next step? The next step is to find another function that's on the outside. So in this case, that would be the sine function, right? That we're focusing on ourselves. So in this case, we're going to differentiate the sine function. We leave this untouched, so 2 sine x cubed plus 2x squared. Okay, we're going to multiply it and differentiate it. So sine, we know as you differentiate is cosine x cubed plus 2x squared. Okay, so that's the second stage. Now the third stage is obviously to differentiate the remaining inside term. Okay, so this is our first stage. Okay, so we're going to call it out 1. Okay, this is a strap, by the way. Out 2, and of course this would be out 3. Alright, and we're gonna leave the rest untouched, so it'll be 2 sine x cubed plus 2x squared multiplied by cosine x cubed plus 2x squared, and then of course we're going to multiply the last outside one, or basically what we would call it as the inside. Alright, we're going to call it the inside. Alright, the most inside of all. Alright, okay, cool. So what we have here is 2x plus 2x squared plus 4x. Okay, is it 2x squared plus 4? Sorry, my bad. It's supposed to be 3x squared plus 4, actually. 4x, supposedly. 3x squared plus 4, right? Because you're differentiating, so it should be 3x squared plus 4x. Okay, so here I made a little mistake, actually. Sorry about that, guys. It's supposed to be 3x plus 4, right? 3x squared plus 4x. 3x squared plus 4x. Okay, so yeah, so you see, this is our final answer. It's actually the same answer, right? They're the same answer, actually, but the only difference is basically the time taken with the in and out method. Okay, the in and out method actually saves a lot of time, or actually I think I should call it more of a out and in method, actually, right? Out and in. Okay, oh, what is it? Out in. Whoops, supposed to be out and in. Okay, We'll call it out and in, by the way, right? It's a parody of the In-N-Out restaurant, lol, but it's just the method itself, alright? So the whole purpose of out and in method is to look for which, how do I say, which terms or which parts of the function are outside and differentiate it first. Okay, so in this case, we know that powers usually get the highest priority because they tend to be outside of the function itself. So that's why we differentiate it first. Then after that is of course the sine function, right? The sine function is the second outside function, or like the middle function you can call it. So we differentiate it with respect to the sine function and got our cosine. Now the last function, which is x cubed plus 2x squared, is very embedded inside, so it's embedded actually, right? So it's an embedded function, right? It's embedded inside, so that's differentiated last, and then we get the answer itself. So it's basically chain rule, but it's much faster because you don't have to obviously take out and substitute. For example, I have to substitute instead of u or v or z or whatever letters you want to use and substitute. It's going to be very tedious, especially if you have a very lengthy function. So therefore I recommend actually to use this modified version with chain rule out and in, which is exactly the chain rule but with less steps, and will save a lot of time in the long run, especially when differentiating with very long functions. Alright, so without further ado, let's go to some questions and yeah, try to solve them, try to find the derivative of these functions. Okay, let me just clear that out real quick. Okay. With that being said, alright, let's look at some questions first. Okay. So the first question is actually pretty straightforward. So we have a function of fx, okay, represented as cosine to the power 4x. And of course, find the derivative, find f, the derivative of x. Okay, I'll give you guys about some time to pause this video and give it a try. Okay, so since I'm assuming that you guys already tried this out, it's pretty straightforward. We use the out and in method, right? We're gonna use the out and in strategy, right? So for the out and in strategy, well, how it works is that we know that fx is equals to cosine of x to the power of 4. So we of course differentiate the outside power, so it becomes 4 cosine cube x, okay? And then later we differentiate the inside, which is x obviously. So of course we're going to multiply that, and differentiating x will be just 1, okay? So we're just left with 4 cosine cube of x. So that wasn't so bad. That was very straightforward. It was a very simple question actually. Let's try a little bit more interesting or challenging question. Let's just spice it up a bit. Right. Okay. Have a look here. Let's look at ourselves. Okay, let's try this. Oh, okay, I think this is quite an interesting question. Root 2 plus cosine of 2x. Okay, so find. Okay, so I'm gonna give you guys a little bit of time to try to solve this question or find the derivative of this function. Pause the video and give it a shot. Okay, so assuming that you guys already paused the video, so we're gonna of course use the same strategy again. So we're gonna use out and in. Okay, the out and in strategy. So how does it work? Right, so fx is equivalent to 2 plus cosine of 2x to the power of half. Yep, so the power of half. So as we find the derivative of fx, what happens So it's half, okay, times 2 plus cosine of 2x to the power of negative half multiplied, okay, so we're going to of course differentiate the inside term right here. So differentiating it would obviously lead us to cosine of b negative sine of 2x, right? But also don't forget that we have the 2x, by the way, so you differentiate it, so we'll end up having a 2, okay? So of course half and half will cancel out, giving us 1. So we'll have negative sine x, or sine 2x, sorry, multiplied by 2 plus cosine of 2x to the power of negative half. So in this case, we can of course rewrite the equation as sine 2x over square root 2 plus cosine of 2x. So yeah, this is basically our derivative, okay? And this wasn't too bad. Let's go for another one. Let's see what we have here. Let me try something, an example. Okay. Okay. So let's say we have this function right here. Okay, this is quite interesting, by the way. So 1 plus x squared, okay, and this is multiplied by the inverse tangent of x. Okay, so of course find f prime x as usual. So I will let you guys have the opportunity to pause this video and try working it out, and yeah, later we'll work it out in a few seconds or a few minutes from now. Okay, so assuming you guys have already paused this video and give it a shot, let's try to solve this problem together. So f of x is equals to root 1 plus x squared multiplied by the tangent inverse of x. So this one obviously we need to do product rule, right? So I'm gonna have to split into two parts, u, and we'll split this in terms of v. So we know that u is equals to 1 plus x squared to the power of half, and du dx, also we're going to use the out and in rule, so we're going to bring the half to the side. It becomes 1 plus x squared to the power of negative half, right, multiplied by 2x. So therefore we're left with x over 1 plus x squared to the power of negative half, or if you want to simplify, just x over root 1 plus x squared. Okay, cool. And for v, all right, it's basically the, maybe I right here, I think, for the lack of space. For v, okay, it is just tangent inverse of 1x. So dv dx, I think if I'm not mistaken, it should be 1 over 1 plus x squared for the derivative of tangent inverse. And yes, it's 1 over 1 plus x squared. So of course we do the product rule, right? So meaning to say that f prime x is equals to v du dx plus u dv dx. So it is just v is tangent inverse x, du dx is x squared, so we're going to write it as x tan inverse x over 1 plus x squared plus u, which is just root root 1 plus x squared. dv dx is just simply over 1 plus x squared. Okay, so yeah, that's pretty much about it for doing this derivatives, right? Since we just use product rule, and of course we use the out and in technique, right? The out and in technique. Okay, so yeah, so that's about it for this part. Let's look at some more questions, I think. Okay, let me see, where can we have some interesting questions? Okay, I think I found one. Oops, let me raise it. Make it big. Okay. Reduce it a bit. Okay. Hey, sorry, I forgot to erase the questions. My apologies. Okay. So let's see. The last question I want to give was this. Right. So it would be sine inverse. Okay. X minus 1 over 2. Okay. So I'll let you guys pause the video for a bit and try to find the derivative of this function before we resume. Okay, so assuming you guys have paused the video and give it a try, so let's try it together actually. Again, this is very straightforward. We just use the out and in strat, or the strategy, okay, as I like to call it. So the out and in strategy, very simple. Okay, so fx is just equals to the sine inverse x minus 1 over 2. Okay, so of course we look at the outermost, which is obviously the sine. They'll get the first priority. Then of course we look at this x minus 1 over 2, which will get the second priority. Okay, and you know, to be fair, when we do the differentiation of sine inverse, it should be 1 over, so 1 over root 1 minus x minus 1 over 2 squared. Okay, and we're not done yet because we still have to differentiate this. So x over x minus 1 over 2, actually you can rewrite it to be half x minus half, right? So it becomes much simpler when you think about it. Just multiply it half, that's it. And if you were to simplify this function for the derivative, right, so it becomes f derivative of x, so it become 1 over 2 root 1 minus x minus 1 squared over 4. Okay, and of course you can further simplify this problem, but again the main objective was to simplify an f derivative of x, so this is already quite sufficient. Alright, and if you want to further simplify it, that x minus 1 squared over 4 and minus 1, you can feel free to do so. But yeah, that's basically how we find the derivative of this function. Now I think we'll just end this video with one last function I just like to give. Right, and let's use this function right now, the last one. Okay, so the function is like this, right? So fx equals to the root of 1 plus sine cube of x. Okay, so this is the last function, right? And again, I'll give you guys some time, right? So please pause the video and try to attempt this problem, okay, before I proceed. Okay, so assuming that you guys already paused and tried out this method, we're gonna use the same strat once more, out and in. Okay, so we're gonna use the out and in strat. So how does the out and in strat for this function goes? So we have fx equals to 1 plus sine cube x to the power of half. Alright, so the outermost obviously is the root or the exponent power. Remember that you know, of course, we have root of x is obviously equals to x to the power of half. Yeah, just to remind you guys that. So this is the outermost. Okay, so the one get the highest priority. Then of course it would be this particular function, I'll get a second priority, right? Priority number 2. And the last priority, okay, I'm going to highlight it, and maybe I'll highlight white, I think, would be the x. This would be the innermost function, right? So let's tackle that. Okay, let's start. So it would be f prime x equals to half 1 plus sine cube x to the power of negative half, or multiply. So we differentiate 1 respect to x, you don't get anything. Okay, by differentiate sine, we get what we would get here, about 3 sine square x. Okay, so actually my bad, I forgot to mention one more thing. This would actually be the fourth, sorry. So this would actually be our fourth point, yeah, because I did forget that we also have the case for sine cube. That would be our third, right? Sorry, I mean the sine itself is the third outermost function, right? So yeah, okay, so just to clarify that, so 3 sine square x times cosine of x and times with 1, right? We differentiate x, we get 1. So we get 3 over 2 sine square x cosine of x times 1 plus sine cube of x to the power of negative half. Okay, and yeah, that's pretty much about it. So this is basically our derivative. Okay, and yeah, that's pretty much it for this video, where we discussed about trig functions. We already talked about trig functions and the out and in strategy, right? So out and in, oops, I always write out in like that for some reason, I don't know why, but yeah. So we talked about out and in, and we talked about trig functions, right? So in the next video, what we can expect is we'll talk more about exponential functions, logarithmic functions, probably the natural log functions, as well as hyperbolic functions. Okay, so yeah, that we can expect from the next video. And of course we'll talk about the stuff I mentioned last time: parametric, implicit, and of course we'll follow by optimization problems. Okay, so yeah, thanks for watching, guys, and I'll see you in the next video.